All right, this is AP Calculus. We're still on the 4-1 notes. We left off yesterday talking about how to write the line of how to write the equation of a tangent line. And tangent lines are still used to estimate functions. They don't give you the exact values. So when I have my point over here, I'm given generally a point given this information. So let's come out here and say that we knew that, let's say f of 1 is equal to 2. So the way that we are analyzing this in calculus is we say that f of 1 equals 2. And I think we're all familiar with function notation by now. What is the x, what is the y in this statement?
So the x is f of 1.
Nope, not quite.
The y is f of 1.
These are the two numbers. Which one is x, which one is y?
Y
This one or this one?
is 1.
Y is 1?
Yeah.
No. So 1 is the input. This is the input.
Wait, that's
This
what
is
I
the
said.
output.
You just said no.
You said f of 1.
Oh, I just meant that one.
Well, no, it's just 1, exactly, yeah.
Oh my god.
So this is saying this whole thing right here is equivalent to 1 comma 2 disguised in here.
Oh, that makes. Sorry.
Okay, so then we can graph that 1 comma 2. So we come up over here 1, we come up 1, 2, and then we would also have a function. Usually they're going to give us the actual function. So they'd say something, or maybe they'll just give us the slope. They'll say something along the lines of f prime at that 1 is equal to, we'll say 3 or something. And that's trying to tell us that the slope here, so this whole thing is telling us that the slope at that point is equal to 3. And then we could make that line, the same line over here. Maybe I should do that in a different color. That slope at that point is 3.
Did you hear my jaw pop?
Yeah, why does it keep doing
I
that?
don't know. But like,
Does it hurt?
no, it just pops. Like, I don't know. Like, I realized that was really loud when I was like,
All right, so
wait, is there something that hurt?
given this information, let's write the equation of that line.
Like, what photo?
All right, the equation. Come on, girls.
Slope,
I feel like, I don't know.
point, or point slope form?
In point slope form, yes. I want the equation of that line that I just drew.
So would it be y minus 2
Y minus 2. So far, so good.
equals 3 times 1 minus, or I mean x minus 1.
X minus 1. There it is, yeah. So we plugged in our point. Our point was 1, 2. We kept the minus signs. And we made sure our slope was plugged in here as well. Perfect. We found the equation. And then let's say we want to approximate our point 1.1. So what we do is we plug in our 1.1. Remember 1.1 was the point that we wanted to approximate. We can plug in that 1.1 and have that come into
So the reason
our
why
x.
X minus 1 is because you flip the signs?
Yeah, you always have the signs flipped, I guess, if you want to think about it that way. I guess if you want to think about it flipped, that's one way to remember it. The other way is just that they're both negatives.
I have a question.
Yes.
Okay, so like the point that you're approximating, how do you like draw a limit on that? Like how do you say that's too far, like that's not close enough, or like what's like the...
Yeah, it's drawing lines in the sand. There's no good way of saying it. Just really, really close.
But that's not how math works.
I know. And that's why these are only estimates. And once you get to college, so this was actually one of my favorite classes, was approximating. You learn Newton approximation, you learn Runge-Kutta, you learn a bunch of really advanced ways of approximating, and each one gets better and better, and you learn how to analyze the errors. So each one, I can't remember what, this error is linear, it gets really bad really fast. Runge-Kutta is a little bit better. I don't even remember very much about which one was the best, but you can learn how to analyze these errors. In calculus, we're not going to do that. There's already too much that we're memorizing. So we could plug in 1.1 and get the value of y out of here to figure out how close 1.1 was. I do expect you to be able to do this on the test. I don't think I'm going to have you do it in the homework. Let me just check.
What the heck? How am I supposed to practice it?
I don't think I have you approximate, but you can plug this in. Let's just have it in our notes. If I plug in 1.1, then I get 3. What's going on here? What the heck?
Whoa, you drew like a flame. Yeah.
We'd have 3 times 1.1 minus 1 is equal to y minus 2. And then you keep going through here. 1.1 minus 1 is 0.1 times 3 is 0.3. And then we're going to add the 2, so it's 2.3. So y is equal to 2.3. So the change from here to here is 0.3. Now, do you girls think that that is an overestimate or an underestimate? Remember, we just found right here at, this was 1.1, we found that that height is 2.3. Do you think that is an overestimate or an underestimate? And I really encourage you to look at this graph right over here. The point on this line, underestimate or overestimate?
Under.
What?
I think it's an under.
I haven't heard from Rosalie, Kaylin, or Isabel.
Wait, so.
The point on this line, 2.3, has to be on this line. In terms of the function that it's actually estimating, is this point an overestimate or an underestimate for the actual height?
And on f of 1 you got... Oh, it's an underestimate. 3.
Because it's a little less than 3.
So it should
There
be...
it's 2.3 and there he did it less than 2.
So haven't actually given you what the actual value is at 1.1. We can estimate that it was 2.3. At 1 we knew it was 2 and then it changed by 0.3. It is an underestimate because this point on the line is slightly under this point on our
Well, that's what I
parabola.
was thinking, but then I thought that was just like dumb because like you just can't draw it quickly or something.
No,
but like that actually is.
that is the logic, yeah. But you have to be careful here because they're not always going to give you a graph. You are going to have to be able to tell, oh, well, this is concave up, and it's on the positive side, increasing at an increasing rate. Therefore, our approximation is going to be an underestimate.
Would it
So then-
always be an underestimate? Oh, I guess if you had like a Arctic graph or something like that, and you had like the curve concave down, it'd be an overestimate.
So yeah, let's
So
just
then
draw
what
those
would it
really
look
quick on the
like if
side.
it was an overestimate?
Yeah, I want to draw both cases. I'll do it on the side notes here.
What can we write out like?
It's an underestimate.
So say you had
It's an underestimate.
a point, let's just do both of these. So if I have a point here and a point
What am I?
here
No.
that's actually on the parabola, and I draw a line, and I want to estimate the black dot. So somewhere, maybe I should go like this. I think this is the best way.
Color coding.
I know. I want to estimate at that value. I want to estimate at this value and at this value.
Say what?
Wait, honey, it's a whole neighborhood.
So in this case,
I think really
if I'm on the line of the tangent on my first case, is this going to be an over or an underestimate?
It's an under.
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 I think
Estimate.
Oh, yeah. Well, then it's
What about this line? Is this line going to be an over or an underestimate?
over. I'm not exactly scary.
Here are two examples. You could have had them on the other side over here. But these, I just want to give you two examples of what an under and an over look like. I could have done them on a different type of graph. I could have done them on the left over here. Let's not copy this down, but I want to kind of, no, copy this down, but what I'm about to write, don't copy down. So if I do something over here, and I make my line is solid blue. Actually, I don't even have to do that because I can actually change my line to become right here. If I came over here, would that be an underestimate or an overestimate over here?
On that one?
Yeah, on this new line.
Straight in the middle.
It would be exactly perfect. I don't know.
No, like so on the to the left of the point.
Under.
It's another underestimate. And if I did another point over here, hold on here. Another point over here. Come on now.
You're very confused.
Are these all going to be under, or are they?
Yeah.
Is one of them going to switch?
It's gonna
That
switch
one will-
eventually because it's gonna be part of the composite.
That's still under.
Yeah,
So-
that one is still
It's
under.
still under.
So right there, still under, and right there, still under. All of these are underestimates. Even over here, all of these are overestimates. Why?
So like
Because of the curve.
Because of the curve, exactly. What about the curve?
One's negative, one's positive.
Yeah, so what do we call the curve in calculus? Starts with a C again.
concave.
Concavity, yeah. So one's concave up, one's concave down. That will change whether it's an overestimate or an
I
underestimate.
feel like it sounded like 30 years ago.
And it kind of goes opposite, right? So if it's concave up, it's an underestimate, and if it's concave down, it's an overestimate. I'm not 100% sure if this rule is always true. So I'm going to say it's 90% true. I feel like there might be a case where it's not, so I'll have to check this
But
later
also,
tonight.
If we're not given a
Make it
graph,
make
then how
sense.
are we supposed to tell?
By the double prime test.
Oh, and you can. Oh, that makes sense.
Yeah. All right, so let's look at an example here, and then we can move on to the homework.
Mr. Sandell, are you sure we're gonna have enough pages for this year?
No.
I'm not sure.
I think
You
I'm
buy a
gonna
Mondo badass notebook.
Yeah, it's gonna have a very good.
How many pages did you have? You had 70?
I had 100.
I think you should have enough. I think the beginning just looks really mega because you have like pre-test worksheets, like 2 worksheets per, so it looks really thick, but I think we should be good. All right, I want to go to one more new slide.
Spilled coffee. I could rich white girl over here.
Maybe.
I'm fine if we go into a new
I have a
one,
lot of extra.
but I just want to make sure that one
And I
gets
don't
filled as well.
Yeah, I think too.
All right.
Like I buy like 5
Girls,
years and I-
stay with me. Examples.
Okay.
Okay, I'm with you.
I think I'm only going to do one. Here we go. The only problem that we're going to have on here.
Examples.
Yeah, I know.
Now I have to erase the S.
Okay, let's erase the number, erase the S. Example. Okay, so I'm going to tell you that f of x, our function, is 5x squared. And here are my instructions. Find the tangent line to our function, f of x, not g of x or h of x, at the point x equals, we'll go with 1. All right, that's all I give you. I only give you an equation and the instructions. Find the tangent line. I do tell you a little bit more information. X is going to be 1.
So plug and chug to find y.
Plug and chug to find y. Okay, so let's do that. Let's find y. So f of 1, if I plug in 1, I get 5 times 1 squared, which equals
That was a joke. I was like saying
5. So now we have our coordinate point, right? Our coordinate pair. We have 1 comma 5. Perfect. What else are we missing?
Do we need to take
slope.
Slope. How do you know that we need slope?
It says
Because of the
tangent
last
line.
problem.
It's a tangent
Part
line.
of the equation.
Yeah, it's part of the equation. Like, if we tried writing out this equation, we would write it all out and we'd be like, wait, we have a blank square. So that's why I really like this form. It tells you exactly what you need to find.
So what we're aiming for, our answer will be that equation with everything filled in.
Exactly, yeah.
It's like y.
And then we're done. Yeah. So we know that we're missing f prime, so how are we going to do that?
Do the f prime. Take the derivative. I
Take
meant.
the derivative. Okay, so f prime
Okay.
of x, that's going to be what?
It's 10 x.
Okay. Cool. That looks like, is that the slope, 10?
Yeah.
No.
Careful here, because we have to plug in
One.
1. So f prime at 1, and it happened to be actually be 10.
Yeah, what? Because I'm like, no, be careful. And it is 10.
So if x was something else, the slope wouldn't be.
Yeah, if I said at x equals
But
2,
it's half
then it would be
that.
20 over here. Yeah, so always make sure to plug in your x into your derivative. And if you want to make that a note, because you might forget, we can make it a note on the side.
Okay.
Always plug in x to the derivative. And maybe you don't like writing out the word derivative and you just want to say f prime. Into f prime.
Can I have some water?
You guys really owe me. Everyone drinks my water. I'm sick.
Just because you got
If
the
I
best
ever
one.
get
So writing out our full equation, we had y minus, and this is a form that you guys need to memorize.
Oh yeah.
Oh my god.
Why are you asking if you want to take a drink of my stuff?
Like if you're that worried, just like don't drink anybody else's drink.
Chris is secretly
All right, what goes in this box?
Really?
in the stomach. I'd be like, can I have a bite? He's like, yeah, get your own spoon.
Oh,
So that will be the y coordinate, which
Yes.
is 5. Then equals the slope, which is 10. Then x minus 1.
There it is, and I can rewrite it all out again to make it look cool. X minus 5 is equal
Make
to
it like that.
10 times x minus 1. Yeah, there. There's the equation of the line tangent to
We're done?
x equals 1. That's it. Yeah, done.
Oh, it's gonna be easy.
Yeah, but
Just
we.
wait.
And now
Yeah,
we
it's
do
probably gonna be
summary.
like an E.
Yep, summary.
Do you have to
Bye.
distribute the 10?
Wait, are we not saying bye?
Bye,
Yeah,
boys.
no, you could distribute the 10 to get it into mx plus b form, but no, this is it. That's the answer. All right, yeah, say goodbye, everyone.